In this video, we will see about CT testing, that is current transformer testing. Before we get into testing, first we will understand about CT, how it behaves in switchgear and how many types of CTs available. Okay, for that we have to study about three-line diagram. See, this is a switchgear three-line diagram. So if this see here, this is bus A, bus B, bus C, that is R, Y, B. Okay, so this is three phase. This is actually 4.16 kV switchgear. Okay, suppose consider this switchgear is energized. If this switchgear is energized, means this bus will be, power will be available, correct? So this power will available up to this breaker front side. See, this is a 4.16 kV breaker. So once this bus is energized, this power will be available up to the front side of this CB, correct? Once this breaker is closed, this power from front side will extend up to load, correct? So now once this load will be any kind of load, whether it is motor, whether it is transformer, maybe UPS, any VSDs, any lighting loads, whatever it may be. Okay, in our case we will consider it as motor. Okay, so once this breaker is closed, power from bus line will extend to motor. Okay, once motor starts running, it will current, this power will start consuming current to motor. Okay, so this, consider this motor full load ampere is 1200. Okay, once this motor attains the full load, this motor will start consuming 1200 ampere, right? So this 1200 ampere will start consuming from this bus bar through the voltage flows 4.16 kV voltage, correct? Okay, so if here this bus, if here in this bus R phase, Y phase, blue phase, red, yellow, blue, if 1200 ampere, if this current flows here, how we can able to read this 1200 ampere? We cannot connect ammeter directly to this bus lines. Ammeter is analog meters, correct? This, if this analog meters are not electrical components, it is instrument components. If you connect ammeter directly to this bus lines, this ammeter will be gets damaged. So same this case applicable for relays also. This, if you connect this relays directly to this bus bar, this relays will get damaged, it will be burnt. So to overcome this, we are introducing CT, current transformer. See here, A phase, B phase, C phase. For each phase we are introducing CTs. For this is for R phase, and this CT is for yellow phase, and this CT is for blue phase. Same here also, A, B, C. So if this CT will be, there is ratio. In our case we are using 200 by 1200 by 5. Okay, see here, this CT ratio is 1200 by 5. What it means, if in this bus 1200 ampere if it flows, this CT will read this 1200 ampere and it will give in secondary 5 ampere here. Okay, this 5 ampere will go to relay, and this relay will read this 5 ampere and it will show us 1200 ampere by configuration. Okay, so if this relay shows 1200 ampere, then we have to understand that this bus is flowing 1200 ampere. That means this motor is consuming full load. Okay, if suppose this motor is consuming 600 ampere, then in this bus each phase 600 ampere will start flowing. Then this current transformer will read 600 ampere from this bus lines for each, from each phase. Then in CT secondaries there will be 2.5 ampere. Okay, so in R phase here 2.5 ampere will flows, here in Y phase here 2.5 ampere will flows, and in blue phase here 2.5 ampere will flows. Okay, this 2.5 ampere will go here to A phase, B phase, C phase relay, and it will read as 600 ampere in primary. So this relay shows 600 ampere, we have to understand that in bus 600 ampere is flowing. Okay, this is CT. So CT purpose. So this CT is multi-ratio CTs. See here we have X1, X2, X3, X4, X5. So 5 secondary terminals. So 5 taps we have available. Okay, so this is multi-ratio CT. Okay, so in full tap, that is X1 to X5 is 1200 ampere. So here this is CT taps. This manufacturer will give us this details. Okay, suppose see here X1 and X5 is full tap. In full tap 1200 by 5. See here, if you read this X1 and X5, we will get 1200 by 5. Okay, if in primary 1200 ampere flows, if you measure X1 and X5, you will get 5 ampere. That is this 1200 ampere tells us information. Okay, now see here X2 to X5, that is 1000 by 5. Okay, X2 means this one, X2 means this one, X5 means this one. If you measure here, if primary flows 1000 ampere, in secondary X2 and X5 will read as 5 ampere. Okay, same like this X3 and X5, X3 and X5, this one. If here 900 ampere flows in primary, if 900 ampere flows in secondary, that is X3 and X5 will read as 5 ampere. Same like this all. Okay, so see here minimum current is here X2 to X3. So this X2 and X3. If in primary 100 ampere flows, in secondary, that is X2 and X3, you will get 5. So this manufacturer designed a CT turns according to this nameplate. So now in our design we want to get X1 and X5. If in primary 1200 ampere flows, we have to get X1 and X5 5 ampere. So we take full tap, X1 and X5 we take. See here X1 and X5 we take. Same like this in Y phase X1 and X5 we take, and blue phase X1 and X5 we take. All this H1 side we will take it, and other X5 we will short and we will make neutral earthing, and we will make us neutral. Correct? So this is how this multi-ratio CT behaves. Okay, so this multi-ratio CT ratio is 1200 by 5, and this class is C200. Okay, this is the constructional details of current transformer. Okay, so here see, this is single ratio CT, single tap. Here we have only one tap, X1 and X2. So this ratio is 1200 by 5. So here only one output, X1 and X2. Same for R phase, Y phase and blue phase. So this is multi-ratio CT and this is single ratio CT. Here we have 5 taps. Okay, but here we have only one tap. Okay, so this is two different kinds of current transformer, and one more current transformer we have, that is GSCT. What is GSCT? For that you have to know about, we have to read this schematic diagram. Here it shows GSCT. GSCT means ground sensing current transformer. Okay, some people will call it as CBCT, current transformer, core balance current transformer. Here it is mentioned as ground sensing current transformer. This ground sensing current transformer is located in load side. Okay, this is switchgear. Up to here is switchgear, and this part is cable part. See here, power cable. So our motor cables will come here and it is connected in switchgear. Here it will be connected like here. See here, here and here, here. All 3 phase will be connected. So here there will be a ring type CT, just like hollow. I will show you in diagram and I will show you in actual also. So for 3 cables, it is just like bangles. How ladies wear bangles, same like this, there will be a hollow shape. And for this 3 cable together will go in this CT. Okay, so in normal condition, this if motor consumes 600 ampere, in R phase 600 and Y phase 600 and blue phase 600, that time the CT will read as 0. If any fault current occurs in any one phase, that fault current will get induced in the CT and it will go to relay. Okay, so this is the core balance CT. Normal condition, this phase 600 and this phase 600 and this phase 600 all together get summation and this output will be 0. So in normal condition, this CT output will be 0 and there will be no any current flow. If any one phase fault, suppose in this yellow phase, if any fault, suppose any cable got damaged, then there will be a short circuit, correct? That ground fault current will be gets unbalanced and will get induced in this CT secondary and it will flow to relay and it will detect the fault current. If this fault current is more than the setting, then this relay will give trip to this breaker. Once this breaker gets trip signal and it will be tripped, so this motor will be protected. Okay, this is how this CT will behaves. Okay, so now for this CT we have to, before getting to testing, we have to know which is P1 and which is P2. Okay, we have to study first which is P1 and which is P2. See, now power flows from this direction, correct? So power flows from this direction and then it goes to load. Okay, so first, before going to testing, you have to know where is P1. See, suppose for this CT, here they mention H1 and here see this is dotted line. So here see this is dotted, they put dotted and they put here H1. So this is H1, meaning power flows from H1 to H2. Here they will not mention H2, they will mention only H1. H1 means primary side. Okay, so power flows from this side and it leaves like this. Okay, so we have to consider here this P1 and here as P2. Same for this CT also. So same for this CT also, this upside is P1 and downside is P2. So because current flows from here. See here, but for this CT, downside is H1 and upside is H2. That is P1 is downside and P2 is upside, because this CT is used for bus differential purpose. So for this I have put separate video very clearly. You cannot find in any other YouTube channel this much very clear. So I have already uploaded for this CT how it behaves for bus bar differential. Complete testing for bus differential I have put, bus bar stability. You can watch that one also. Okay, so here this for this CT power flow will be from downside. Okay, so first you have to understand this. So now we will see how this CT is going to be tested and how we have to give connection. Okay, so for this we will read, start now. Okay, see here. So this is our Vanguard test ticket. So in Vanguard test ticket we have secondary cable connections and primary cable connections. See here, first we have to connect Vanguard primary cables. Okay, first before start any connections, you have to first earth this test ticket. Okay, then this primary cable, now you have to test this CT. Okay, in switchgear there will be many cubicles like this, many feeders you will find. Here I show 3-line diagram for 2 feeders like this. Next, suppose this is bus bar, here one feeder, here one feeder, here one feeder, here one feeder, many feeders there will be. So here you see 2 feeders available here. So in this 2 feeder we are going to test this CT. Okay, now here R phase, this R phase CT we are going to test, this R phase multi-ratio CT. Okay, for this we have to first find where is H1 and how to access this H1 bus bar. Okay, now this test kit have primary cables like this. So once this cable is connected here, this one end will be goes like this, and after a certain point there will be 2 cables separated. Okay, So this two cable will be, one is H1 and other one will be H2. Okay, so this H1 cable we have to connect here, and H2 cable we have to connect here. This is other cubicle and this is other cubicle. We are testing this CT, correct? For this CT, which is primary, this bus bar is primary, correct? We have to connect one cable. H1 is here and H2 is here, but this bus bar is enclosed. You cannot access this bus bar. This bus bar, all switchgear is closed, so you cannot open this door and you cannot connect here. For that we have to take next cubicles or face, okay, and this cubicle or face and this cubicle or face. Before connecting, you have to make continuity. In multimeter you put continuity mode, and this or face and this or face you have to connect cables and you have to check continuity. And before checking continuity, you have to close this breaker on condition. Make this breaker is an on condition and this breaker is on condition. Next you put continuity here and here. Once you put continuity, there will be a closed path and you will get buzzer sound that confirms, that ensures that this is the closed path. So if this confirms this closed path, then you can connect H1 here. You cannot connect H1 here and H2 here, because then the polarity will be reversed. If you connect this H1 here, see here, this H1 will flows here, correct? Like this closed path will go and it will comes here and it will comes here and it will enters here. See here, if it enters here, the CT's H1 will be upside, correct? So we have to connect here. See here, H1. If you connect this H2 here, then this H2 will go here and 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 it will enters here. Then this will be a wrong polarity, because CT upside we need H1 cable from test kit. So this, due to you cannot access here, we take next cable as reference feeder. So you have to connect here. Okay, if you connect here only, this H1 will forms a closed path and this H1 will enters in CT here. Okay, so here you have to connect H1 and here you have to connect H2. In same case, if you want to test this CT, then you have to connect H2 here and H1 here, because see here, this CT upside is H2, this CT upside is H2. In this case, you have to connect this H2 here and this H1 here. Now we are testing this CT and upside we need H1. For that we have to check like this bus bar, like this going and like this coming and this enters. So here you have to connect H1 cable. Once you start testing, finish, you completed R phase CT, then you can go to, then you have to connect this cable here and this cable here in Y phase. Once Y phase CT finished, you have to connect this one here, blue phase, and this one you have to connect blue phase. Like this you have to complete this testing this CT. Okay, now we will see the R phase CT. Once you connect test kit H1 cables here and H2 cables here, so primary cable connection finished. Next, secondary cables. We have 5 taps. We are going to test multi-ratio CT, right? And our multi-ratio have 5 taps: X1, X2, X3, X4, X5. Here we already see, no, X1, X2, X3, X4, X5. We have 5 taps. For that 5 taps you have to connect. So this here, the secondary cables will be like this. So this cables, one end will be 2 connections and other end will be 1 connections. So these 2 connections like this you have to connect, and after a certain point these 2 cables will come in one and it will go to here. Now you have to connect like this, okay, in X1, then X2, then X2 cable you have to connect here, X2 CT secondaries. Okay, so like this all 5 cables you have to connect in here: X1, X2, X3, X4, X5. Okay, so before connecting, test kit connections, you have to remove the external cables which is going to relay. Okay, also you have to remove this earth point. This earth cable also you have to remove. Okay, if you connect this earth cable and if you test, there will be a error, percentage error will be more in CT ratio. So better you remove this earth cable. Okay, so from this test kit X1, X2, X3, X4, X5, this all cables 5 taps will connected in here like this. Okay, so now we connected H1 and H2 cable and we connected secondary cables. Okay, so this is the test connection. So before connection, you have to make test kit earth, then primary cables you have to find where we want to connect H1 and where we want to connect H2. According to diagram, you have to connect. If this H1 and H2, if you wrongly connect, then your polarity will be failed and CT ratio will be more. So to proper checking and to test properly, you have to see first this diagram, where is H1. According to that H1, you have to connect this. Okay, then you have to connect this CT secondary cables like this according to our schematic. All 5 taps we have to connect. Okay, once this connection is completed, you can start power on this test kit and you can start proceeding the testing. Okay, this same test connection will be applicable for CPC 100 test kit, Vanguard and CT analyzer. Every test kit will have 2 sets. One is H1 and H2 and other is secondary cables. In whether it is CPC 100 or Vanguard or CT analyzer, you will have 2 sets. That is primary cables and secondary cables. Primary cables will have H1 and H2. You have to see schematic diagram and you have to connect same like this, H1 here and H2 here. Same like this secondary cables you have to connect. For all test kit, connections are common. Only thing, you have to check this diagram. You have to understand this diagram, how to connect H1 cables and where to connect H1 cables and H2 cables and how to connect the secondary cables. Before connecting secondary cables, from terminal block you have to remove this secondary cables which is connected to relay, and earth cable you have to remove and you have to start testing. Okay, this is the connection for multi-ratio CT. Okay, now we will see about this CBCT connection, how to give connection for this CBCT. Okay, so see here, this CBCT connection, I already told this switchgear, when this is up to switchgear bus bar and this is cable which is connected to motor. So this cable, when in construction time, there will be not available. So we have to put a temporary cable in this CT and we have to give connection. Once this test is completed, then this temporary cable have to be removed. Okay, see now here there is only one tap, G1 and G0, that is secondary cables X1 and X2. So this is not multi-ratio CT, this is only single ratio CT. We have only one tap. Okay, for that we have to use X1 and X2. Other all taps we don't want to use, we left alone. Okay, so after this earth cable is connected to this test kit, we have to connect this primary cables. So here already we found where is P1 and where is P2, that is where is H1 and H2. Power flows from upside to downside. So upside is P1. Then this test kit's primary cables, that is H1 you should connect upside and H2, that is P2, downside. This we will see in actual video. We'll continue our practical test. In side test you can able to see very clearly. Before getting into actual test, you have to see this schematic diagram and study the schematic diagram. Then only you have to start performing the test. If not, there will be some danger. Okay, that's why I am explaining very clearly. Okay, see here, before we starting this connections, earth cable have to be open. See here, I already opened this earth cable. Earth cable is disconnected. In this terminal block we have to remove this earth connections, earth cable. Okay, then secondary cable X1 and X2. So see here, this X1 is connected to this G1 and this X2 like this coming, and it will connected to G0, that is X2. So G1, G0 is wire number. In this wire number we have to connect this CT secondary cables. So primary cable will be connected in P1 and P2, and secondary cables have to connect in X1, X2, that is secondary cables, and earth cables we have to remove. Okay, so now we can test this CT. This CT ratio is 50/5. Okay, so you can give connections. Now I already explained how to give connections, correct? Now once you start the test, it will give the result. Okay, everything is okay now, but nobody don't knows, many engineers don't know how this testing works, where this voltage is giving and where this voltage is receiving, whether it's this leg is going. See, this is the test connection, how this voltage is going. Now I will tell you. Many engineers and many testing professionals don't know, so now you are going to understand. Okay, see here, once you start testing, the voltage from X1 X2 will go here. Okay, like this the voltage will get into the CT secondaries. This CT secondaries voltage gets induced in primary, and this voltage will again like this, it will go and it will enter this test kit for analyze. Okay, that I have explained very clearly here. See here, consider this as ring type CT. This is core balance CT, GS CT, current sensing current transformer. This CT we are going to test in actual. This actual video is going to come in continue of this video, you can watch it. So here you see H1 and H2. So power flows from bus side to load. Okay, so our test kit cable H1 you should connect here and H2 you should connect here. So CT have two sides, H2 here and that side H1. So that side H1 means this bus bar entering point is here, and you have to connect in H1 here. Okay, and H2 is here. Same X1 and X2. This is single ratio CT, correct? Single tap. So only one tap we have. This X1 should connect in X1 and X2 should connect X2 like this. Okay, so once you switch on this voltage, test kit will start injecting voltage like this ways. So this X1 and X2 injecting this voltage to CT secondaries. So this voltage in CT secondary will got induced in primary side as H2 and H1. So from there this bus bar gets voltage by induction, and this induction voltage will go like this into test kit inside for analyzing the results. Okay, so test kit will inject voltage through X1 and X2 to CT secondaries. This CT will deliver induction voltage to this bus bar, and this bus bar voltage like arrow marks will get enter into CT inside for further analyze the results. Okay, so this is more important. You have to understand this philosophy, how this connections and how this circuit behaves. So without this, if you test this CT, you cannot get the proper knowledge. Okay, so this is how we are going to test this CT both. Now I have explained how we have to study this CT details and how this construction point of view we have to check, and how to connect multi-ratio CTs and how to connect single ratio CT, everything. Okay, we have to ensure the connections. Okay, see here, this test kit we have to give first earth connection to our substation grid. Okay, after that test kit we have primary cables. This primary cable we have to connect. See here, H. This cable other end will be H1 and H2. According to schematic diagram you have to connect. Okay, and here since we are going to test single ratio current transformer, we have only one tap. So we have to take only X1 and X2. Other X3, X4, X5 we have to left open. Okay, see here, this is USB PC cable. This other end we have to connect in laptop. After connecting this cable in laptop, we will get laptop interfaced with this Vanguard test kit. Once we make communication, from after that this Vanguard will be controlled and accessed by laptop. Okay, so here we have a power connection we can give power connection to this test kit, and here we have MCB. Once we switch on this MCB, our test kit will get power supply and switched on. Okay, let's we switch on the test kit. See here we have MCB. So once you switch on this MCB like this, your test kit will get switched on. Okay, now our laptop will get interfaced. Okay, in laptop we have to create a test plan. For that we have to open this software. This is the software for Vanguard. Okay, so here you see new, we have to click this new, and you have to create a test plan. I will tell this. So for in Vanguard we have to create a test plan. If you want to test CT current transformer in Vanguard, you have to create a test plan and you have to save in desktop of your laptop. After you save this test plan, then you have to bring this test plan to this software and you have to run this test plan. Once your test plan gets run, completed, CT testing is finished. Okay, so you have to click this. After you open this software, you have to click this run and you have to open this page. Once you open this page, you have to enter your company details and CT details like this. See here, I am entering this company and station and circuit and manufacturer of CT, everything. Whatever you need to enter, you can enter. Once your company details you enter finish, you have to start entering the CT details, and which ANSI code you have to type, you can type that one, whether it is IEEE or any other you have to type. So we are going to test only single ratio, correct? We have only secondaries X1 and X2. Our CT ratio is 50/5. So you have to select X1 and X2, and CT ratio 50 in primary and secondary is 5. So now you are going to test ratio test, excitation test and winding resistance, correct? So you have to enable all three. See here, ratio test. If you not enable this ratio test, you cannot test this ratio test. Only excitation and winding resistance you can test. So you have to enable all the three. Okay, now excitation voltage. Your excitation voltage you have to see from manufacturer and you have to click enable according to that. Now here I enabled 300 and excitation current is 10. I have enabled according to your nameplate of CT. You can select this one. Okay, so here current ratio error calculation, how much error calculation you can put, and here see burden is up to 500. You can select in nameplate. According to nameplate you can select. If suppose your burden is 50, you can select 100. If your burden is 100, you can select 200. Okay, now CT secondary is 5 ampere, so you can select 5 ampere. Okay, now you have to perform run test, means you have to enable run. Okay, see here you have to enable this option here, then only your test report will show your test is pass or fail. And here you see CT type, what is your class, that one you have to mention here. And what is your CT, where is your CT location, whether it is circuit breaker or it is in transformer bushing, like this you have to select. So in our case it is circuit breaker, so we selected circuit breaker. And this CT is used for metering or protection, that you have to select from here. And here you have this IEEE, which ANSI, according to which ANSI code you are going to test, that you have to select here. And this voltage deviation 20% or what is that, and the resistance deviation 5% or what is that, you have to select, and then you have to click OK. So once you click OK, your test plan, all details you are selected. Okay, now after selected, you have to save in desktop. See, like this you have to save. Now I am going to save in desktop. Okay, I am putting some name, whatever you are going to test, you can create some names. Okay, now I am going to save in test plan desktop. Okay, so this video is going to be little bigger, so for a brief understanding, you can, now you have to bring this test plan in this software. Okay, already we saved in desktop, correct, as AK plan. So now I am searching and going to bring this software here, test plan. After bringing this test plan, we have to run it. Okay, test plan is nothing but you have to enter the details, CT details and company details. Okay, and you have to save. Again you have to bring through run option. Okay, now see here, now we bring, once you press yes, test starts running. Okay, see here. Now we will see the test connection. See this primary cables, H cables like this will go. Now we have to connect in CT. I told this is a construction time. This time power cable will not be there. So we have to connect a temporary cable as we discussed in schematic diagram. See here, I installed this temporary cable according to our schematic diagram power flow. Upside is H2 I connected and downside I connected H1. Okay, like this we have to connect a temporary cable. This temporary cable should not let down, so I put cable tie and I tightened. Okay, so you can find here our CT ratio is 50/5 and relay class is C10. Okay, see here, inside this our R phase, Y phase, blue phase power cable will go inside. So now for testing purpose we can put only one cable for primary, as you see. Okay, now we have to connect CT secondary cables. So CT secondary cables only X1 and X2, since our CT ratio is single core, only we have one tap, other all we have to left open. Okay, like this we have to connect. So other end we have to open this terminal box and we have to connect. We have to remove the earth cable. See here, this green color cable G and D I removed. Other G1 and G0 which is coming from CT I have connected. We have to remove this cable, our CT test kit Vanguard cable we have connected, and that G1 and G0 is going to CT secondary. So now we connected primary cables and secondary cables. Okay, so now we can run the plan. So we can start the testing. So we can execute the testing. Okay, so from test kit that emergency push button should be released. Okay, and earth kit should be earthed. Make sure that. Okay, now we will run this test plan. For that we have to press this yes. Okay, that's all. So now test begins. Okay, so this Vanguard will automatically charging this transformer and discharging this transformer will be automatically done. So you don't want to discharge anything. Okay, so now see 14 volt, up to 14 volt, 15 volt gets injecting. This Vanguard start injecting up 14 volt and 15 volt through X1 and X2, and by induction voltage this primary cable will get into test kit. I already show the power flow. Okay, according to that this philosophy will work. Okay, so now CT is getting magnetizing. Once CT gets magnetized, that is charging, automatically it will be demagnetized, that is discharging. So this test kit is highly safe. So now we have to give here continue. This is just an interlock. We have to give continue. If you not give continue, test will not be performed. Test will not go to further next step. You have to give continue. Okay, so here you can see how much current CT is consuming while testing and how much voltage CT is consuming while testing. Everything you can see here. Okay, in this display also you can see in laptop. I will show you. Okay, I have two separate videos for both that we can check it. So now test result automatically generated. Okay, here you can see the CT ratio, excitation voltage and winding resistance. See here, IEEE 30, IEEE 45 and IEEE IEC 10/50. In all ANSYS code the result is coming. Now CT ratio is 50/5, correct, and our error percentage is 1.231. This error percentage big, and winding resistance is 85.03 milliohms, and excitation voltage is 4.4 and excitation current is 0.73, and phase angle is in phase, that is CT polarity is okay, pass. So this test is pass. Okay, so here error percentage little bigger. This is because I have connected this CT primary cables some loose connection. Once you tighten this CT connections, your result will be okay. That is error percentage will be less than 1 and 0.5 like this. Now you have to save this test report. Okay, you can save this test report and you can print out and for client purpose. Okay, that's all. This test is completed. Further this video will come that you can see for better understanding what is happening when testing. So I have take video in laptop separately and test kit separately. When you are testing, what is happening that you can see in next coming videos. Okay, and you can also see this error percentage. I retest this CT after making these loose connections into proper connection. That time your test result will be less. This error percentage will be less. Okay, that also you can see. That's all. Test gets completed here. If you want to see further, you can see it for better understanding. Okay. Test plan. We have to bring our test plan from desktop and we have to run this software. Okay. Now see here. Now we have to press this run and you have to bring this test plan. After clicking this run, you have to go to desktop where we store our test plan. Okay, in desktop we store our test plan as AK plan, correct? We have to bring this AK plan to this software. Okay, after press yes, test got starting, correct? Now see, test starts running. This is the laptop recording video. You have to know what in laptop showing. That's why I take a separate video. Okay, so see here, all it is coming: running excitation test status, running test, and running long voltage excitation test, everything, low voltage excitation test, everything here will come. Okay, after a certain point of view there will be continue or abort. You have to press continue to further testing. Okay, that is just like interlock. That's why I take a separate video here. Okay, see here. In this video also see here. Now we have to press continue. Okay, don't forget that. In this video also error percentage will be more because this is same video which we tested before. Okay, so in this, so don't get confused. Next video will come. This after 1 minute there will be other continuation of this video. There I tighten this test cables from Vanguard. After I make tighten, that result will be error percentage will be reduced to 0.5 like this. Okay, most of the client will not accept if error percentage is more like 1, 0.8 like this. So error percentage should be less. Okay, so this is how this test report will generate automatically. Okay, here you can see the CT ratio 50/5 and error percentage 1.7. This is too much, so most of the client will not accept. Okay, so you have to make sure your tightness. So here winding resistance, everything will come. Okay, this is how this is how laptop display will show you. Okay, so in 2 minutes test will get completed. Okay, see here in phase that you can see here. I record this test kit and laptop together. Okay, so you can get more knowledge. So what is happening in test kit and what is happening in laptop, you can see both. Once test kit starts, this high voltage present light will blink, so you can make sure that voltage is present. So when you are testing, you should be very much aware of this barricade safety point of view. Okay, when you are testing CT, other engineers or any other technicians should not interrupt your CT or switch gear. Okay, so danger may be happen, so you have to put barricade and you have to test very safely. Now see, light starts blinking, that is this test kit start delivering the voltage. Okay, this CT magnetizing and demagnetizing will automatically done by this test kit. You don't want to discharge this CT anything. Okay, so don't want, it is 100% safer testing. Okay, now you have to give continue. See here in laptop it shows continue. Okay, once you start giving continue, again this voltage, this light starts blinking, that is voltage is giving. So once test report is generated, you can verify that error percentage is very less here. Before error percentage is more due to loose connections in CT secondaries and CT primaries. I make this tight and this is retest. Here you can find this error percentage is very less. So error percentage should not be more than 0.5 or 0.6. How much error percentage is less? This test report is good. This CT condition is good. Okay. Your testing CT is whether it is in good condition or not. Okay. So see here, error percentage is 0.5170. Okay. So this is acceptable. If error percentage is more than 1, that means CT is defective. So see here, winding resistance also less, 32.87. Now you have to compare this result with nameplate of CT.